All right, 8.2, squeeze theorem. So I know that we went over this already, but I'm just going to do a quick overview of it, okay? So basically, sometimes we have a function that we can't find the limit for. And we know so many different ways of finding the answer for limits. So we can use L'Hopital's, we can use principle of dominance if there's like infinity involved, we can factor, we have these special rules. So we have a lot of methods. I'm going to teach you one more method, okay? So this method is called the squeeze theorem. It's also called the sandwich theorem. So like in our book, it's called sandwich theorem, but a lot of times it's called the squeeze theorem. The reason is because basically they're saying if we have a situation where f is between two other functions, so we know that it's like bigger than something but smaller than something else, then when we find the limit of this and the limit of this and the limit of this, if these two are the same, then we know that this answer, right? So if they both equal like 7, and it says 7 is less than or equal to something is less than or equal to 7, well then that must equal 7, right? That only makes sense. So that's basically what the squeeze theorem is getting at. So what I tried to remind you earlier is basically the squeeze theorem, like it'll give you answers, yes, but sometimes you already know the answers because we know so many methods for finding limits. So we want to think of the squeeze theorem really as like, okay, this is a methodology and this is how we're going to prove something using the squeeze theorem. So you're just going to like make sure that you're able to write everything very clearly and show that you're using the squeeze theorem, okay? So for the first example, it's just, all right, how would we find the limit as x approaches 0 of f of x? Well, if this is true, then I just need to find the limit of f of x. So I need to find the limit of each portion. So then I write the limit of each portion, and then I can find the limits of the left side and the limit of the right side. And if you plug in 0, you get 5. So it only makes sense if this is between 5 and 5, well, this has to equal 5, right? Like that only makes sense. So we say, therefore, by the squeeze theorem, and then we, write it nicely. The limit as x approaches 0 of f of x equals 5. Okay, so one more like that, and you should be able to do that on your own. And you're finding the limit as x approaches 2 of f of x. So find that on your own, and then you're not going to copy, you're just going to check your work. Okay, and then it gets a little bit more interesting. Are you ready? Okay, so let's say you have something like this, because that part's easy, all right? So let's say you have something like this. So find the limit as x approaches 0 of x sine of x. Can you find the answer to this? Absolutely. You can plug in 0 and you get 0. You can plug in 0 and you get, so sine of x is also, or sine of 0 is also 0. 0 times 0 is 0. The answer is going to be 0. I already know that. How would you find this answer using the squeeze theorem? Okay, so this is, like, we're starting off on how you would do it, okay? Even though using another method, you could get 0. All right, so the big thing to remember is for sine and cosine functions, they look something like this. So think about the unit circle as well, but they both look something like this. Cosine is, starts up here and goes down and back up and so on. But we know the y value is between -1 and 1. On a unit circle, the y value is between -1 and 1 as well. So we know sine of x is between -1 and 1. So that's what we start with. But then we want to find this. We want to find x sine of x, and then we want to find the limit. So what do we do to all three portions? We multiply by x. And then we find the limit. Oops. And then, I'll cover that. And then you actually plug in the 0, and then you get 0, and it only makes sense that this whole thing has to equal 0 then, right? So therefore, by the squeeze theorem, that must be true. All right. Another one. How would you start it? So instead of this, how would you start it? So you have to start with what's between -1 and 1? Cosine. Cosine of something is between -1 and 1. And then x squared. All three sides, so multiply by x squared. and then find the limit of all three. And actually, like, so this part is really important. If you skip from here to here, we're okay. But you can't skip from like here to here, okay? So start here, and then if you get to here, that's okay. And then you have to write the next step. You have to actually find the limit of the left side and the right side. And it only makes sense that that would be true, right? Okay, one more similar but different. Let's see. All right, so how do you start? Negative 1, 1, what's in the middle? All right, what are you going to multiply? And what kind of limit? So remember, this says infinity, so be careful about your infinity. Now plug in infinity. What's 1 over infinity? What's negative 1 over infinity? It's 0. All right, final answer. Okay, so I'm starting to notice something, and I don't know if you notice it too. I'm noticing that that's equal to 0, that's equal to 0, that's equal to 0. I look online, and all these examples are equal to 0 when it has to do with sine, cosine. But I promise you, because I like to mess with you so much, my answers for the quiz and the test or whatever, they will not all be 0, okay? I promise you. I will figure out a way. Okay, so here is the last example for squeeze theorem. This one's different. What do you start with? Negative 1 and 1, what's in between? The cosine, and then e to the power, and then multiply by x, and then the limit. Okay, so how can you make this faster? You need this step, and then I would say you need this step. So definitely this one, and then maybe skipping to that one, okay? And then go ahead and plug in. Oh, you plug it in, you get 0, plug it in, you get 0. Okay, fine, this one is 0 as well. This final answer is 0 as well. However, like I said, I am going to find a way for that answer to not be 0, all right? Okay, so your homework is right here. If you want, you can write it on the right side where you have room, that's fine. And these are all the theorems that we have learned in calculus. Your quiz will have all of these theorems and, you know, probably a bunch of different limits, because I want you to do just random limits. I want you to use L'Hopital's. I want you to use the principal of dominance. I want you to know it all, you know, by now. We can do it. Okay.